Hello guys, in this section I'll be talking about calculus. What is calculus? Calculus is the Latin name for stone, which was employed by the Romans for calculation. Now, calculus is sometimes called infinitesimal calculus, which implies the calculation of numbers which are infinitesimally small. Now, a little example to throw a light on what infinitesimal numbers are. Now, let's consider the growth of a small plant. In the ordinary, we know that it grows gradually and continuously. Let's say we try to examine the growth of a small plant after an interval of, let's say, few days. The growth is obvious and we can measure it. But let's say we try to examine the growth of the small plant at an interval of, let's say, a few minutes. Okay, few minutes, it cannot be. It can be distinguished. We can see that growth exists, but we cannot measure it. Now let's say we try to examine the growth after an interval of a few seconds. It cannot be readily measured. The mathematical expression that is used for this is called infinitesimal small. That's infinitesimal calculus. Infinitesimal calculus. So for the growth of that small plant, that is infinitesimally small. We cannot measure it. Now, under calculus, we have what we call function. Function. Now, the example I used, which is the growth of a small plant. Now, the plant is a functional relation. The factors which are moisture, sunlight, and temperature depends on the growth of the plant. But if these factors, if they are constant, then the growth of the plant is said to be a function of time. The growth of the plant is said to be a function of time. That means the growth of the plant depends on what? On time. Now also we have variable and constant. We have variables and constants. Now of the letters and symbols that is used to represent quantities or number in an algebraic expression or quantities or algebraic equation rather. So some represent variables and some represent what? A constant. Now let's consider the volume of a sphere. The volume of a sphere, which is V is equal to 4/3 pi r cubed. This volume of a sphere, this V is called the volume of the sphere, and the r is the radius of the sphere. Now this volume and radius, they are what? They are variables. While the pi and 4/3 are called what? They are the constants. The pi and 4/3 are called constant. Also, we have the dependent variables and the independent variables. Dependent variables and independent variables. Now here, in this equation, in this formula rather, V is equal to 4/3 pi r cubed. This V is called the dependent variable because it's depending on this value r as for its own value, it's depending on r. But this r is called independent variable. Also, let's consider this y, which is a function of x. This y, which is a function of x. This y is called the dependent variable. It's depending on x for its own value. Why x is what? Independent variable. Does not depend on what? On y for its own variable. Now, example of this, let's say we have y is equal to the square root of x squared plus 1 is a function. Y is equal to 1 over what? X plus 3. Y is equal to 1 over x. They are what? They are functions. Now, y is the dependent variable and x is what? Independent variable. Now also we have the notation of the increment of a function. The increment of a function. Now let's consider y, which is a function of x. Now if there is an increment in x, the increment in this x is denoted by this, or the increment in x is denoted by this or this. Now this del x is not written as delta times x, which is contrary to the ordinary use of algebra. Because we know from algebra 2x is equal to what? 2 times x. But here the increment is not equal to del times x. We take it as what? Del x. Now, if there's an increment in del x, since we know that y is a function of x, y depends on x for its own value. X is what? Is an independent variable. So when there's an increment in x, there will be a corresponding increment in what? In y. So if there's an increment in x, if the increment in x is taken as what? Del x, and the increment in y is taken as what? Del y, and we know that y is a function of x. Y depends on x. If there is an increment in x, then y will receive an increment in what? In y. So that's giving us y plus del y is equal to f increment in x, x plus del x. Then we can take del y as f x plus del x minus y. So del y is f of x plus del x minus y, and y is what? Function of x. That's the notation for the increment of x, increment of the variable x and increment of the variable y. Now let's talk about the graphical representation of a function. Now the graphical representation of a function. Now let's consider a function y is equal to x squared. Y is equal to x squared, or if y is a function of x, and that means f of x is equal to what? X squared. Now let's consider the graph of what? X squared. Now let's try to input some numbers. Let's try to input some numbers. Let's take minus 3, minus 2, minus 1 is 0, 1, 2, 3. Now let's take the range of values of this number. Now here, f of minus 3 is the same thing as minus 3 squared, which is 9. And f of minus 2 is what? Minus 2 squared, which is 4. Then f of minus 1 is minus 1 squared, which is 1. F of 0 is 0. Now f of 1 is 1 squared, which is 1. F of 2 is 2 squared, which is 4. And f of 3 is what? 3 squared, which is 9. Now here we can see that f of a is the same thing as f of minus a. Because when we input a, let's say we input minus 3, we get the same result when we input what? 3. So f of a is equal to what? F of what? Minus a. Is an even function. Even function. Even function. Now, let's plot the graph of this. This is my y, which is a function of x, and this is my x. Now, this is the values of x. 0, 1, 2, 3. 0, 1, 2, 3. Minus 1, minus 2, minus 3. And this is to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when x is minus 3, remember y is a function of x. Y is a function of x. So this y is the function of x, and this is the function. Function of x, this is x minus 3, and y is what? 9. Minus 3 and y is 9. Somewhere here. Minus 2 and y is 4. Here. Minus 1 and y is 1. Here. 0. Y is 0 and x is what? X is 0, y is 0. X is 1, y is what? Y is 1. And x is 2, y is 4. And x is 3, y is 9. It's like this. So the graph of y is equal to x squared is like this. This is the graph of y is equal to x squared. Now let's continue with the next one. That's differential coefficients. Differential coefficients. Differential coefficient. Now, what is differential coefficient? The process of finding the differential coefficient or the derivative of a function is called differentiation. So, differentiation means finding the differential coefficient of a function or the derivative of a function. That's what we call the differential coefficient. Now, the general form of differential coefficient is this: the limit at which del x tends to 0 of f of x plus del x minus f of x all over del x. Now let's say y is a function of x. If y is a function of x, if there's an increment in x, then y receives an increment in what? In y. So that's y plus del y is f of x plus del x. That's the increment. So del y is taken as f of x plus del x minus y. And my y is what? F of x. And I can divide all through by what? Del x. Dividing all through by del x, that means the rate of change of the increment in y to that of the increment in x. That's f of x plus del x minus f of x all over del x. Now, the rate of change of the increment in y to that of x. You can take the limit of del y, the increment in y, over the increment in x, at which del x tends to 0. Taking the increment in the rate of change, that gives dy dx. So we have it as dy dx is equal to f of x plus del x minus what? F of x all over what? Del x. So that's why we take the limit. This is the limit at which del x tends to 0. So we divide by the increment, that's del x, then we take the limit of the function. Another one is the derivative coefficient of a function. The derivative coefficient of a function. An example on the derivative coefficient of a function. And let's consider this. If y is equal to x raised to power n, find the derivative of the function. Now this method is what we call the first principles. The method. Now if y is equal to x raised to power n, now n is an integer. Now we know that y is a function of x. If there's an increment in x, then y receives an increment in what? Y. So that's y plus del y is equal to x plus del x raised to power what? Raised to power n. Now that gives y plus del y is equal to x plus del x raised to power n. Now expanding this from the right hand side, expanding the right hand side using the binomial expansion, that gives x raised to power n plus nx n minus 1 del x raised to power 1 plus n minus 1 x n minus 2 del x raised to power 2 all over 2 factorial plus n minus 1 n minus 2 x n minus 3 del x raised to power 3 all over 3 factorial. Because that n is what? It's an integer. We don't know where it's going to. Now, this is y plus del y is equal to x raised to power n plus nx raised to power n minus 1 del x. Now, this is del y. If I take this y to the other side, that becomes minus y. And the y is taken as what? X raised to power n. So that gives x raised to power n minus x raised to power n, because y is what? X raised to power n. If I take it to the other side, this cancels out. So that gives nx n minus 1 del x plus n minus 1 x raised to power n minus 2 del x raised to power 2 all over 2 factorial. I can decide to stop here. n minus 1 n minus 2 x raised to power n minus 3 del x raised to power 3 all over 3 factorial. That's it. Now the next thing to do is to divide all through by what? By the increment in x. That's divided by the x. So that's finding the rate of change of that. So that's the y over the x is equal to divide all through by the x. That gives nx n minus 1 plus n minus 1 x n minus 2. So dividing this one by the x, that gives the x all over 2 factorial plus n minus 1 n minus 2 x n minus 3, that's the x raised to 2 all over 3 factorial. Now the next thing to do is take the limit of the rate of change, the y del x, at which del x tends to 0. Then you take it as dy dx. So taking the limit, this becomes dy dx. Note the x here, that's nx n minus 1 plus n minus 1 x raised to n minus 2. The x tends to what? Is 0. That's the limit. Is 0 over 2 factorial plus n minus 1 n minus 2 x n minus 3. That's 0. When the x tends to 0, the limit over 3 factorial. So that gives dy dx as what? Nx raised to n minus 1. This is what? 0. So the derivative coefficient of y, which is equal to x raised to power n, is what? Nx raised to power n minus 1. Now what about the derivative coefficients of y? Let's say we have a constant, that's a x raised to power n. This is a constant now. And normally if there's an increment in x, there will be an increment in y. So the increment will not affect the constant. Just take a, then x plus the x raised to power n. So we have it as y plus the y is equal to a. Now the extension of this, the right hand side, just the same thing. So I can just decide to stop here. Let me stop here. So that's x raised to power n plus nx minus 1 del x plus n minus 1 x n minus 2 del x is power 2 all over 2 factorial plus. So that's y plus the y is equal to, use this constant to multiply to ax is power n plus anx n minus 1 del x plus an n minus 1 x n minus 2 del x squared all over 2 factorial. Now this y is ax is power n and there's ax is power n here. So if I take it to the other side, this cancel out. So that means the y is anx n minus 1 del x plus an n minus 1 x n minus 2 del x squared all over 2 factorial. Now the next thing to do is what? Find the rate of change of the increment, dy del x. So divide out 2 by what? Dy del x. So this out, divide here, that becomes an n minus 1 x n minus 2, that becomes del x all over 2 factorial. Now after, take the limit of dy del x, the rate of change of the increment at which del x tends to 0. That becomes dy dx. So write as dy dx is equal to anx n minus 1. Why this is what? Del x tends to what? Is 0 plus 0. So the derivative coefficient of y is equal to ax raised to power n is anx raised to power n minus 1. Now the next thing to do is the derivative coefficient of a constant. Let's say we have to find the derivative coefficient of a constant using first principle. The derivative coefficient of a constant using first principles. Now let's consider a constant y. Okay, let's consider a function. A y is a function of x and that of a constant. Y is equal to mx plus c. This c is a constant. Now, how do we find the derivative coefficient of this? Y is a function of x. If there is an increment in x, there will be a corresponding increment in what? In y. So that's y plus change in y. So I can even write it as change in y like this, the same thing. M x plus change in x plus c. That's plus c. No increments in c because y is not a function of, it's just a constant. So plus c. So that's y plus the y is equal to what? M into bracket x plus what? Del x. So that's the y is equal to mx plus del x plus c minus y. So the y is equal to mx plus m del x plus c minus my y is what? Mx plus c. So that gives the y is equal to mx plus m change in x plus c minus mx minus c. So this cancel out. Mx cancel out. That's change in y is equal to m change in x. So the next thing to do is what? Divide all through by the increment in x, change in x over change in x. Then after, that's the y is equal to del x is equal to m. So after take the limit of the increment at which del x tends to 0 as what? Dy dx. So this becomes dy dx. So there is no dx here. There is no del x to take it as what? Is 0. So the answer is what? M. That's the limit of the constant. Is still what? M. So now we see that using first principle, the derivative coefficient of a constant is equal to what? Is 0. That's because we cannot find the derivative coefficient of a constant. We can only find the derivative coefficient of a variable. So the derivative coefficient of a constant is always what? Always is 0. Now, the last example to a little light on that. Let's consider y, which is equal to 1 over x, using first principle. Y is equal to 1 over x using first principle. Find the derivative coefficient of this. Now, if there is an increment in x, there will be an increment in y. So that's y plus change in y is equal to 1 over x plus change in x. This is still the same thing as x raised to power minus 1. So the y is equal to 1 over x plus change in x minus y minus 1 over x. So that is the y is equal to x minus 1 into bracket x plus change in x all over x into bracket x plus change in x. So that's the y is equal to x minus change in x all over x into bracket x plus change in x. So the y is equal to minus del x all over x into bracket x plus what? Change in x. Now this del x here, I can take it to this side. It's just the same thing as divide all through by the rate of change of x all over del x. So what do I have left at the numerator? That's minus 1 all over x into bracket x plus change in x. So the next thing to do is what? Take the limit of del y del x at which del x tends to 0 as dy dx. So this becomes dy dx, which is minus 1 over x plus del x tends to 0. That's the limit. Is 0. That's minus 1 over x squared or minus x raised to power minus 2. That's the derivative coefficient of that. So don't forget, differentiation means finding the derivative coefficient of a function or the derivative of a function. And also, these are the representation or the notation we use for derivative coefficient. If y is equal to function of x, finding the first derivative coefficient of this function, that means d dx of f of x, or I can write it as d dx of f of x is still the same thing. That means finding the derivative coefficient, which is the same thing as f prime of x. This is first derivative. When I say first derivative, I mean finding the first derivative of a function. If y is equal to 1 over x, so the first derivative coefficient of the function, which is dy dx, is minus x raised to power minus 2. But finding the second derivative, that means I need to differentiate this again. That's what we call the second derivative. So the second derivative is d dx of dy dx again. Because the first derivative coefficient is d dx of the function. Now second will be d dx of the first derivative coefficient. So that gives the 2y all over dx squared, which is given as f prime prime of x. The third becomes d dx of the 2y all over dx squared. That is the 3y all over dx cube. That's f prime 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 of x. Now the nth derivative coefficient of the function, the nth, so that becomes the ny all over the x raised to power n. That's f n of x. That's the derivative coefficient of the function. Thank you for listening.